Hello guys, welcome back to Manalasak. Hope you guys have been well. So this is a grade 11 video for number patterns, and the topics that you see here are the things that I want to discuss. I want to keep this as a short video, so I'm not going to waste your time. So disclaimer, like always. In fact, it's not a disclaimer, it's like a tip, or both tip and disclaimer. You need to have a pen and paper and a calculator for you to be able to absorb as maximum content as possible from this video. So I want to start with the idea of linear patterns. Now, if you're watching this video and you're in grade 11, this shouldn't be a real problem to you because we've worked with linear patterns before, right? In the previous grades, they might have explained the linear patterns to you this way, or they might have explained the linear patterns to you what is the other way? Other textbook, they put it this way. So it doesn't really matter how you understand it, but the main part that matters, it's the understanding this way, right? So whichever way you might have done it in the lower grades, it's okay, we accept it. Basically, in linear patterns, we are saying that the numbers, they should be the same units apart. Like to move from 4 to 7, we added 3 plus 3, right? From 7 to 10, we added 3. From 10 to 13, we added 3. And here we also added 3, right? So whatever we are doing, either through addition or subtraction, it must be the same, right? For example, let's say we have 37, the next value is 33, the next value is 29. And I'm sure you can see the pattern here this way. In this situation, our value here, it's minus 4. From there to there, that's minus 4. From there to there, that's minus 4. That's how we find out linear patterns. And then so this situation here, these values, we call them the constant difference. Which means if we are saying that we have a linear pattern, the number that we use to move from one term to the next one, it must be the same throughout, right? It's not complicated, right? So that's the constant difference in that case. So I'm going to move on to just the questions so that we get to see how do we get to work with linear patterns, right? So here I have this situation, and then I want you to recognize this question. Let me highlight it. The general term. Now this will frequently be there. And then how they ask this question can be in different ways. So here actually they did it for us. They said they want the general term. Sometimes they can say they want you to find Tn. Or sometimes they can say find the nth term. So this is the same thing. They can ask you the question this way and say find the general term, or they can say find Tn, or they can say find the nth term. That's how they can ask you this question, right? And then whichever way it comes, you should be able to answer it because it means the same thing. All right. So I'm quickly browsing through this now with an assumption that a person who's in grade 11 now, they know these things. Right, so here's what we have. When we talk about a linear pattern, the kind of an equation I expect you to give me, it's this one, and then I'm going to show some descriptions what these things mean. So first of all, the B, it's the constant difference. Right, remember what did we say about the constant difference in the previous slide, right? So that's what we have here. And then this is the value in position 0. Right, if you can know what is the value in position 1, then you can know that C, it's the value in position 0, basically. right? So the first question, it says they want us to find the general term of this thing. And then usually when you are in that situation, what are you supposed to do, right? So I'm writing down the sequence. The sequence is 4 followed by 7 followed by 10 followed by 13, then by 16. And they even told you this is a linear number pattern, right? They didn't even have to. Sometimes you just actually have to find that out yourself. And how do you find that out yourself? You find that out by checking if you have the constant difference here, right? So to move from here to there, we added 3. From here to there, we added 3. We added 3 here, and we'll definitely do the same here. Now, there's a rule that says the constant difference, you find it by saying the following. You must have your T2 minus T1 be equal to T3 minus T2. This is how it goes. This is how the formula goes. For you to prove that you have a constant difference, T2 minus T1 must be the same as T3 minus T2. How in this case? T2 here it's 7 minus T1, which is 4. This is equals to T3. T3 it's term number 3, which is 10, minus term number 2, which is 7. Here 7 minus 4, that is 3, which is equals to 10 minus 7, which is 3. Right? So we have a constant difference of positive 3 here. Right? So now that we are here, let me erase this. Remember, now I want to answer this question of determine the general term, which means I must find the formula of this sequence, right? So remember what we said about this. This represents our C. So I'm going to say, therefore, C is equals to positive 3. And afterwards we have, sorry, that's B, not C. That's B. What am I doing? Right? This is the constant difference. We said B is the constant difference. I'm happy that I found that out early, that I made a mistake there. And now for us to find C, remember we said C is the value in position 0. So this is position 3, this is position 2, this is position 1. Position 0, it's the value that is supposed to be here, right? So if from here I'm moving from 10 to 7 to 4, when I move backwards, my value here will be what? It will be 1. Right? So which means my C is equals to 1, because my C, it's a value that comes before term number 1. Is that fine? So now when you give me the answer for question A, you're going to say Tn is equals to, where there is B you put it, 3n, then where there is C you put it, plus 1. There you go. You get your 2 marks there. Easy 2 marks to collect. Now question B, not to waste time there. Question B says find the 20th term. Now let me tell you something. After you find the sequence, after you find your equation per se, right? Here's the equation. After you find it, usually the next questions, either they will give you Tn and they want you to find n, or they will give you n and they want you to find Tn. Now, what are these things? Starting with n. N is the position. Right? So when they say 20th term, that's the position. Right? So that's what you're supposed to know. And then when they say question C, which term in the sequence is equals to, that's Tn. That story is Tn. Which term is equals to this number, that's Tn. That number is Tn. But when they want the position, they want n. Are we good? So question B. Question B says determine the 20th term. You first start by writing the sequence, the equation this way. And they want to know which term it equals to this position. They gave us a position, it means they want Tn. So I'm going to say T20 because it's the 20th position. is equals to 3 multiplied by 20 plus 1. So T20 is equals to 60 plus 1, which is equals to 61. Right? Not too bad. The next question, question C, they gave you Tn, which means they want n. Right? You write down the equation again. Tn is equals to 3n plus 1. They gave us this, so you substitute it. 301 is equals to 3 this way. Transpose 1 to another side, right? So it's 301 minus 1 is equals to 3n. That is equals to 300 is equals to 3n. Divide this by 3, divide this by 3. Then 100 is equals to n. There we go. See how doable is that? That is not too bad, guys. So, moving on to the next thing. The next thing we have quadratic patterns. Now, because we spoke about linear sequences. For a quadratic number pattern, things are slightly different now. But if you're in grade 11, you also did this in grade 10. So this is just a reminder. So I'm going to take this, I'm going to first start by saying the general equation. You find the general equation by saying Tn is equals to an squared plus bn plus c. There we go. This is the general equation. You use this now throughout to find Tn, the general term or the nth term of this sequence that you see, right? Now let me write the sequence down. This is 1, 5, 10, and 16. Right? So to move from here to there, what happened? They added 4. To move from here to there, from 5 to 10, they added 5. To move from 10 to 16, they added 6. Right? And look at this one here. To move from here to there, they added 1. To move from here to there, they added 1. Right? So now this is a quadratic sequence. How do you know something is a quadratic sequence? 2 ways. Number 1, they might specifically tell you that this is a quadratic sequence. Number 2, they might give you an equation that looks like this as a standard form. This is a quadratic equation because its degree of this equation, it's exponent 2, right? 3, you can find out that something is quadratic by knowing that it has the second constant difference. Now, remember linear pattern. Linear pattern had the first constant difference. Like, just the first difference was a constant difference. But with a quadratic pattern, the second difference, it's the one that has a constant difference, which means the value that I'm adding here is the same value I'll add here, the same value I'll add here, the same value I'll add here. But that only happens in the second difference, right? So now in this situation, the first line, this one here, represents the quadratic sequence. And then this line here, this one, it represents the linear sequence. So basically a quadratic number pattern, it needs a linear sequence understanding in it. So now here we have a formula that will help you find these things. The formula says, let me choose a pen here, a different color. For me to find my A value, I'm going to say 2A is equals to the first difference. For me to find my b value, I'm going to say 3a plus b is equals to the first value of the first difference, right? For me to find my c value, I'm going to say a plus b plus c is equals to my first value in the quadratic sequence. Very important for you to know them this way, right? So I'm going to pause this here because I want to actually continue with it properly on an actual question that wants us to find the equation. So let's save this first so that it doesn't crash. Let's go to the actual question. The actual question says you have a quadratic pattern here. Here it is. They told you see that now the first thing is that they told you want to highlight this when you're on a test, that you are given a quadratic sequence and that is the quadratic sequence, right? They told you, which means you don't have to assume whether this is linear or anything. You know this is quadratic, right? So first question they're saying choose a white pen, determine the next term, which is term number 5. So this is term number 1, 2, 3, 4. They want term number 5. So when they give you a sequence like this, you want to rewrite the sequence, line it down yourself so that you can be able to work with it properly. I see that to move from here to there, to move from here to there, to move from here to there, right? From 4 to 9, they added 5. From 9 to 18, they added 9. From 18 to 31, here they added how much is that? I'm lazy to even calculate. They added 13. There we go. Right? Should I confirm this? Yes, I should. When you're not sure about things, just confirm them. Right, I'm opening my calculator there. There we go. 31 minus 18. Let me fix the mode. Yes, 31 minus 18, that is 13, right? So to move from here to there, they added 13. Right, so now, and then afterwards, this is the first difference. Remember what we said about the first difference. The first difference is a linear sequence. Right, now I'm going to the second difference. The second difference is supposed to be what? A constant difference. Because why? They told us this is a quadratic sequence. So to move from here to there, they added 4. To move from here to there, they added 4. So we can see there's the constant difference, right? They said they want what? They said they want me to find value that's on the 5th position. So for me to do that, I need to carry the sequence forward the way it looks here. So for me to move from here to there, I need to add 4, which will give me the next value here. That next value will be what? 17. Right? And then to move from this term now to the next one, I need to add this 17 to get to the next term. Let's say I don't want to make mistakes. So just take out my calculator there. And I do that. 31 plus 17 is equals to 48. Which means my next term here is 48. Boom. There we go. They are answered. Right? And then the next question now, which is this one. See what they're saying? Find the nth term. They even gave you a clue here and said the general term. But forget this in the exam. In the exam, they're going to ask you one of this. Determine the nth term. That's it. Or they're going to say, determine the general term. That's it. All right? They're not going to spoil you like this. So Now, here's what we are going to do. We have B, right? And then for me to find that, remember what we said. For us to find that, we need to equate things. We need to remember that the general sequence says Tn is equals to An squared plus Bn plus C, right? And then what did we say in the previous slide? We said we must find these things one by one, starting with A. For me to find A, I need to equate it with this. It said 2A is equals to this value. So let's put it here. 2A is equals to what? How much? 4. Now, if I divide both sides by 2, I'm going to say, therefore, my A is equals to positive 2. Do we see that? Not confusing, right? And then afterwards, I move on. I need to find my B. We said, how do we find B? We must say 3A plus B is equals to this first value here. So I write it here. 3A plus B is equals to 5. And then, but I already have my A. So I'll substitute the A. 3 into 2 plus B is equals to 5. Which means these things together, that's 6 plus B is equals to 5. Right? Then I continue solving for B here. I'll send 6 to another side. So I have B is equals to 5 minus 6. Therefore, B is equals to negative 1. Right? So I have my B, I have my A. Now I'm looking for C. We said, how do you find C? You come here, you say A plus B plus C. You equate it to this first term here. Right? So let's write that down. A plus B plus C must be equals to the first term, which is 4. Then again, we already have A. A is 2. And we just found B now, which is negative 1. Plus C, this is equals to 4. So which means we have 2 minus 1 plus C is equals to 4. And then which means I have 1 plus C is equals to 4. This means C is equals to 4 minus 1. Therefore, my C is equals to 3. And then now I have C now. So I can make substitutions into this equation and write the general term. So the general term is Tn is equals to my A, which is 2, 2n squared, my B, which is negative 1, negative 1n, and my C, which is 3, plus 3. There we go. Not bad, is it? So we can move on now to the next one. This is how we do it. Moving on, we have the following. Another question. The question says, they want us to find the general term of this sequence. And bear in mind, what are they saying? The sequence, which is this one, they're telling you that this sequence is quadratic. Right? First thing, they want you to find Tn. So by now, I'm sure you'll be able to pause the video and see what we did on the, and repeat what we did on the previous slide. Right? So, okay, let's do that. Let's choose a white pen here. I write down the sequence. Let me put it here. 18, 16, 12, 6, negative 2. And then now I get to the linear pattern, right? For a linear pattern, I say from here to there, what happened? We subtracted 2. From there to there, what happened? We subtracted 4. From here to here, we subtracted 6. From here to here, we subtracted 8. Then I do it again this way. To move from here to there, what happened? I subtracted 2. To move from here to there, subtract 2. From here to there, subtract 2. And remember, now we are looking for the sequence. So I need to know that my Tn, the general term, is equals to An squared plus Bn plus C. And then we start with A. The story says, I'm going to take this and equate it to 2A. right? So I'll do that. 2a is equals to 2, which means therefore a is equals to 1. There we go. Right? Next question. I need to not next question. The next thing. I need to find b. The equation says 3a plus b is equals to that first value. Right? So which means here I can say 3a plus b is equals to negative 2. But I already have a. A is 1. Right? Therefore, which means b is equals to negative 2. Transpose 3 to the other side. Minus 3. My b is equals to minus 5. Right? Now I find my c. My c, I'm supposed to say a plus b plus c is equals to this first value here. Right? So I have a plus b plus c is equals to 18. Substitutions. My a is 1. My b is negative 5 plus c is equals to 18. This on the left side is negative 4 plus c is equals to 18. Hope that's visible. Let's fix it. It's not looking good, man. I hate things that are looking ugly like that. So here I have negative 4 plus c is equals to 18. Therefore, here my c is equals to 18. Negative 4 to the other side, that's plus 4. Which means my c is equals to 22. Right? Let's cut some things here. So I can say, therefore, my Tn is equals to a is 1. Say 1n squared. I don't even need to write the 1. My b is negative 5. Negative 5n. My c is positive 22. There we go. Alright. And then what happens? And then here I need to answer question B. Question B says, wait a minute. I made a mistake here. Let me see if I can quickly fix it. But this is a very strong mistake. Okay. Here we go. Here it's 2a equals to negative 2. And I said 2a equals to positive 2. So for me to fix that, I just need to say, oh, hope this won't confuse you. Hope so. 2a is equals to negative 2, not positive 2. So let's fix that. Right? This is equals to negative 2, which means my answer here is equals to negative 1. Boom. Right? And then here, since my a is negative 1, now it affects everything also. I don't know why I made this mistake. Forgetting negatives, it's a rookie mistake. Beginner's mistake. So here I put negative 1. Boom. So it's like I have negative 3. Now when I transpose negative 3 to the other side, it becomes positive 3. Alright. So now, if I have b being equals to negative 2 plus 3, that gives me a total answer of positive 1. There we go. Right? So I have my b here. And now I need to change my substitutions here again for b and c. So my a is negative 1. My b is positive 1. Right? So these things, they cancel out. So I can erase from here now. I'm happy I saw this before I go to the other questions. So now here I have this and this cancelling out, which means I have C being equals to 18. Therefore, my equation, my general term is equals to A, which is -1 n squared, and B, which is +1. Do I need to write the ones? No. And C, which is 18 plus 18. There we go. Now we can answer the next questions with the correct answers. I'm more confident about this one, that this one is correct. Alright, so that fixed. My apologies there. It's very late. It's 20 past 12 now. I need to sleep. It says find the value of Tn. Of T35. The value of T35. Now bear in mind, what did they give us there? Between Tn and n. What did they give us and what do they want? Oops. Let me save this thing. It wants to crash. Between n and Tn, what do they want and what do they give us? What did they give us, right? So basically when they say T15, this n is 15. They gave us n. N is 15. So they're looking for Tn when n is 15, right? You start by writing the equation. Equation says -n squared plus n plus 18. So we are looking for T15. I put T15 is equals to wherever where there is n, I put 15s this way. And afterwards, what do I do here? I don't strain myself. Just pull out the calculator and then punch it there. Let's move things around here so that we can be able to see. So I just have to say -15 square that plus 15 plus 18. That is -192. Right? Not too terrible at all. So the value of T15, that will be -192. Pretty nice. So now question C. Question C says, which term? Oh, you see what's happening? Which term? This is the position. At which n value of the sequence will I have -72? Now, it means they are looking for n and they gave me Tn. Now, equation first. This is the equation, right? Then substitution. They gave me this. With what? -72 n squared plus n plus 18. What do you see? This is a quadratic sequence, right? So I need everything on one side. I'm taking this -n squared to another side, which becomes +n squared. I take this to another side, it becomes -n. I'll take 18 to another side, that's -18. And -72 was already on the left side. So -72 equals to, here on the right side, I no longer have anything, 0 there. So I have n squared minus n. And then here, you know what? The best thing to do, calculator. -18 minus 72. -90. Look at that. -90 is equals to 0. And then, is this factorizable? Factors of 90 that give me 1, of course. It's 10 and 9. Right? These things, they can give me 1. So I do that. Factors of n squared, I have n and n. And then since this is a negative, it means my signs in the bracket will be different, right? For me to end up with a negative answer between these two terms, the bigger number has to be negative. Boom, boom. Then I'm going to say, therefore, n is equals to negative 9, or n is equals to positive 10. Now, here's what happens. We said n. Let's choose a different color because already there's chaos here. We said n, it's the position. Right? This is the position. That's n. So I cannot have a negative position, especially in grade 11. Right? So I come here and I cancel this n being equals to negative 9, and I only keep this one. You see this? You get a mark for cancelling that equal sign. So there you go. All right. So next question. Next question is a more advanced problem. It needs to understand how much do you understand the concept here. Again, they'll always give you clues on what to use. They told you that this is a quadratic pattern, right? And then they say find the value of x. Now you rewrite the pattern yourself. The pattern is 1. You have a 7. You have an x. You have a 31. What do you understand about quadratic patterns? What we understand is that the second difference must be a constant difference. Okay. We'll get to the meanings of those. I know that the answer here is this value minus this value. So 7 minus 1, that is 6. I know that what I should get here, it's this minus this. So that is x minus 7. Are we good? That's what I should get here. And I know that what I should get here, it's 31 minus x. So I write it that way. 31 minus x. So this is linear. Right? That's what we know. And then here, I must have the constant difference, which means these values, they should be the same. But rather, what do I have? I have x minus 7, subtract this part here, subtract the 6. What's happening? Yeah, I'm even drowsy. Minus 6 minus the 6, right? And then I have this part here minus this part should give me this, right? So I'm going to say 31 minus x. I'm subtracting this binomial. Remember, when you subtract the binomial, you put the binomial in brackets, right? And I need to simplify this so that they look like things that make sense, like this. X minus 7 minus 6, that is the same as x minus 13. That's what it is, right? So I'll come back here and erase that and write the proper value there. This is x minus 13. There we go. And then afterwards, I also need to do this one. Here I have, let me simplify it so that it starts to look like something that makes sense. This is 31 minus x. I distribute the negative, so this is negative x, and this is positive 7, right? So negative x and negative x, that is negative 2x, and then 31 plus 7, that is plus 38. All right, so this thing that I see here, it's the same as this thing here. So I write it properly. Let's put this here. Negative 2x plus 38. Let's choose an eraser here and remove this one. Right. And then what did we say about the constant difference? Just like in all the previous examples here, we know that the constant difference, it's the same amount, which means this value and this value, they should be equal. So I apply the same logic here, that this thing here should be equals to this thing. That's because they are constant difference. Right, so I have x minus 13. This should be equals to negative 2x plus 38. What do we know here? We group things that are the same on one side. I'm sending this to another side. I'm going to have 3x. I'm sending negative 13 to another side. That's 38 plus 13. Let's do it. That is 51. Right? And then I say here solving for x, I divide both sides by 3. Which means here I have 51 divided by 3. That's 17. So therefore, x is equal to 17. That's what they wanted, right? They got it. We gave them what they want. So as doable as that, guys. This was very enjoyable. Hope you guys also enjoyed it. Next one. Oh. Okay. There we go. Another problem that is advanced. These kind of problems, they are something else. So first they tell you that, again, keywords. This is quadratic. So which means I'll take this thing, I rewrite it here. Oops, I'm doing errors there. Guys, I'm tired. It's almost 1 now. And then I have to be up by 4. So, and I was awake since yesterday, 3. So I'm actually tired. There we go. Right. So what do I know? I know that this, it's a linear pattern. So I'll just use a calculator for those things. 360 minus 399. To get the first difference, right? That's negative 39. And then 323 minus 360. Don't be scared by big numbers. Negative 37. 288 minus 323. Negative 35. And then 255 minus 288. Negative 33. And then I find the constant difference. From here to there, that's positive 2. From here to there, that's positive 2. From here to there, that's positive 2. Right. So A, it says it wants me to find the formula for the general term. Right? General term. Like, guys, this question, you cannot run away from it. It will always be there. So I'll come here and do that. Like, I'm doing this probably for the 4th time now. You should be able to get used to it. So the general equation says Tn is equals to An squared plus Bn plus C. So my 2a in this situation is equals to 2, positive 2. Therefore, which means my a is equals to positive 1. Fingers crossed, no mistakes this time. So for me to find b, I must say 3a plus b is equals to this number here, right? So 3a plus b must be equals to negative 39. Substitutions. So this is 3. When I transpose it to another side, I'll have b is equals to negative 39 minus 3. That's negative 42. Right? And then, what else? I have to find a. To find a, I must say a plus b plus c is equals to the first number there. So a plus b plus c must be equals to 399. Substitution. My a is 1. My b is negative 42. Let me write it there. B, we say it's negative 42. Plus c is equals to 399. There. So my c is equals to 399. Here I have 41. When I take 41 to the other side, it's plus 41. Therefore, my c is equals to 399 plus 41, 440. Therefore, let me write it here. Therefore, Tn is equals to n squared, our b is what? Minus 42n, our c is what? 440. There we go. Let me clear some space here. So that's our answer for A, to find the general equation. Next question now. It says, this is a tricky one because it doesn't only now test your understanding of sequences. It tests your understanding of the word quadratic. It says, which term of the pattern will have the lowest value? Now, when you say things like that, you should remember words like minimum and maximum. Right? These things, we got them when we were working with quadratic equations. And we know that for us to do that, we must have an equation that is the same as y is equals to a x plus p squared plus q. Right? So now from this situation, we want to have like a moment like that, in a way. Are we good? So how do we get from here to this? By completing the square. So I take this. Tn is equals to n squared minus 42n plus 440. When you complete the square, I'm going to say n squared plus 42n, and then I'm going to say plus 42 over 2 squared minus 42 over 2 squared, and then plus 440. Then I just use a calculator for the other things, but let me write this one. N squared minus 42n plus, let's see this one. I'm going to say 42 over 2, close bracket, squared, 441. Nice. So I'm going to say plus 441 minus 441 plus 440. So Tn is equals to n squared minus 42n. Let me do this. this is equals to white pen. I group this ones together, right? And then 441 is 441 a perfect square. Let's use a calculator there. 441 equal sign shift fact. Let me see. How do you know if a number is a perfect square? You put it under a square root. 441. Yes, it's a perfect square. 21 times 21 is 441. Okay. So we do that. I'm going to say open two brackets. Factors of n squared, it's n and n. We have a plus, which means we must have the same signs, but the same signs will be negative. So it's negative and negative. Factors of 441 is 21 and 21. And guess what? When you add 21 and 21, you get 42. Perfect. Then you have this one. Negative 441 plus 440 is what? That's negative 1. Then Tn is equals to, these brackets are the same. You write them, then you square them this way. Would you look at that? Now we converted this equation from this format to the one of completing the square, right? And then after completing the square, usually what do we say, right? We usually say this graph, it's positive because there's no sign in front. It means it's a positive. So a positive parabola looks like this. And we know that it has a minimum value. It doesn't have a maximum value. Hence, they ask you this question. What is the lowest value you can ever have in this pattern? You see that? You're going to say, therefore, the graph will have the lowest value of this one, -1, when n is the opposite of this number here, +21. There we go. See how nice was that? Super nice. This was very nice. I actually never thought we would enjoy this question. And then next question, of course. Let's wait for it to load. Boom. Another advanced question, another advanced problem. Now this is very advanced. Very advanced. First things first, they tell you that this sequence you are looking at is quadratic. So let's read the thing. Consider the quadratic number pattern, and here's the number pattern. What is the difference between the 50th and the 51st term? Now here, if the examiner throws you with this one, they are not playing. They mean it. This is the last question on the part of sequences. That's where they start throwing you with these things. Right? Will it always be there? No. It won't always be there. So, let's see how do we answer this. So first of all, I want to write this sequence. So since they told me that it's quadratic, I'll look for the first difference and look for the second difference. The difference from here to here, 0. From here to here, 4. From here to here, 8. Boom, boom. Constant difference is 4 and a +4. Now, and then afterwards, they ask you a question like, this is like a banging question right off the bat, right? What is the difference between the 50th and the 51st term? Now, once you get a question like this, you want to narrow it down to what's available yet. So, before I get to the 50th and the 51st term, I want to start with the first and second term, right? The difference between the second and first term gives me the first sequence. Let me put it in writing so that you can actually hear what am I saying. I'm saying T2 minus T1 in quad. It gives me T1 in linear. Hope it makes sense now. Okay. T3 minus T2 gives me T2 here. Let's put it in writing again. T3 minus T2 gives me T2 in linear. Now let's do this one. T4 minus T3 gives me T3 in linear. So T4 minus T3 gives me T3 in linear. This difference in a quadratic gives me this one in linear. All right. So now, what do they want? They want me to find the value of T5. No, what is this? They want me to find the value of T51 minus T50 in quadratic. What should this give me? This is supposed to give me T50 in a linear sequence. Makes sense? What are we doing here? Hope so. Right? So, since we are saying this is a linear sequence now, I can treat this as a linear sequence. What do I know about a linear sequence? It has an equation that says Tn is equals to Bn plus C. That's what I know about it. And then what do I know about B? I know that B is this constant difference. So I'm going to say my B is equals to 4. What do I know about my C? I know that my C is the value before the first value. So this is the first value, this is the second value, this is the third value. Let me take it from here and go backwards. Subtract 4, which means to get here, I need to subtract 4. It means my C value now will be what? My C value will be negative 4. So which means the sequence for my linear pattern is 4n minus 4. I'm talking about this linear pattern. Remember, the first difference is a linear pattern. Right? So, and then we said, what do I want? I made this part here. The difference of T51 and T50. There we go. The difference of T51 and T50 can be found by just finding T50 in the linear sequence. So I try to do that. Going to come here and say, using this, substituting into this, right? I hope you can see it. So I'm looking for T50 in a linear pattern, which will be 4 into 50 minus 4. So T50 is equals to, let's pick out a calculator here, not strain ourselves. 200 minus 4. That's 196. Yeah. What is this? 4 into 50. I'm just doing this so I can show you guys that when you write the exam, use a calculator to avoid making mistakes. 196. So this is equals to 196. See how we got to solve that question. It's a nice level 4 question. If you get this question, don't worry, it's a level 4. It's meant to be difficult. Now, the next question, I cleared the screen there so that we can be able to answer this one problem. No, in fact, I didn't clear the screen. I opened another page. Alright? So, B. Between which two consecutive terms will the difference be 28,088? Right? So, this story here, because I'm finding a difference between two consecutive terms in a quadratic pattern. So, if this is the answer of two consecutive terms, it means this is in a linear pattern, right? Because we know that the quadratic pattern, its first difference is a linear pattern, its second difference is a constant difference, right? So, which means this story here, it's happening in a linear pattern. So, what do I know about a linear pattern? In the previous answering, I found my general term for this linear pattern to be Tn being equals to 4n minus 4. So I'll use that now. 4n minus 4. Are we good? Do you see why are we using a linear? Because this is the first difference of this quadratic pattern. And the first difference of a quadratic pattern is linear. right? And then so if this is the answer of that first difference, it means this thing, it's inside a linear pattern. So what I have here, this number, it is the value of the term. It's not the position, it's the value of the term. So I have 28088 being equals to 4n minus 4. I need to transpose this to another side, right? 28. Now look at me. Look at me confirming something obvious. It's because I'm tired, to be honest. I know the amount of mistakes I can do here. I'm so tired. Plus 4. Of course. 2892 is equals to 4n. So now what happens here? Now I solve for n. When I solve for n, I divide this side by 4 and I divide this side by 4. Therefore, my n will be equals to, take this answer, divide by 4. 7023. Bear in mind, n cannot be negative and n cannot be a fraction, right? So 7023. Right? So now we need to actually answer the question. Now remember what we did here. We said in a quadratic and a linear pattern, this is the relationship. We said T2 minus T1 gives you T1 in a linear pattern. Let's speed it up a bit. We said T5 minus T4 gives you T4 in a linear pattern. Let's do the last one. The last one. We can say T20 minus T19 in a quadratic pattern gives you T19 in a linear pattern. You see what I want to do? So now in this situation, we have our n being 7023. So we have this part here, T7023. They want to know between, let's highlight that, it's the English that matters here. Between which two consecutive terms? Which two consecutive terms? So if I'm able to find this part, then I can find its two consecutive terms using the same thing I've been doing throughout here, right? So if this is found between 273, it means the number here, it's T7023. Like this one, you see how this number matches with this, how this number matches with this, how this number matches with this, right? So this number will also match with this one. And this one will be 1 unit higher, which is 7024. That's how you answer level 4 questions in terms of sequences. So here your answer is going to be, it is found between this number and this number. Boom. How do you like that? I was hoping I do this video under an hour, but it is what it is. If you made it this far, guys, don't forget to sub and like. Apologies for that one mistake I made there. Costed me some few minutes, but I hope you comprehend the rest of the video. Comprehend it. Okay. Yeah. Right. So goodbye, guys. See you on the next one. Don't forget to like and sub. Okay. Yeah. Goodbye.